we're going for platinum level LEED certification, and I'll let Aaron describe the characteristics of the building here.
Basically, I'll start out on the site. We have an IDOT funded roadway coming in, basically kind of where the dirt road is now. Basically wrap around the building to the rear parking lot, and we'll also go down through the woods down to a boat ramp and a boat dock. And at that boat ramp, we will have a river pump placed in the Mississippi River. It'll be capable of bringing up unfiltered Mississippi River water, 1.6
million gallons.
1.8 million gallons a day.
1.7.
So that river pump will bring the river water up to the mesocosms, which will be out back.
Mesocosms are like channelized lanes, like a swimming pool, except they're separated. So you can do 6 different experiments by bringing the water to these channels. So long, narrow channels called mesocosms.
Yeah, they can mimic the flow of the river, and it'll be the only place on the Mississippi River that we're actually bringing unfiltered river water up.
If you're conducting research anywhere in the world and you want to hold the river constant, how do you do that? So this way, it makes it a very unique research facility.
So back out to the roadway. On the roadway itself, it'll be made up of pervious pavers, and the state of Illinois will be using 3 different types of pervious pavers that they've never used before, and the whole state's never used it, so it'll be kind of a experimental roadway for them also. All LED down lighting, no curb and gutter, all bioswales to drain out. This will be a big entrance bridge that you kind of walked over. This stone is in the process. We ran out of stone, and we're having a problem getting it this winter, so it might not be done for a month or so.
Can't imagine how you ran out of stone.
But basically, what you see there, it will have little about 30 to 40 inch high walls wrapping around that, and you'll be crossing over an entrance pond. The pond basically goes 100 yards this way and 100 yards that way. And it will be filled with the means of river water also.
It's like a constructed wetlands, we're calling it dragonfly pond. It's really a constructed wetlands so that school groups can see what a wetlands looks like as they come in the building.
You'll have landscaping set up in different interpretational educational zones with signage kind of stating the benefits of native species and things like that.
All the plants are native plants here and designed for not a lot of need for irrigation maintenance.
The water efficiency items here in the building, we are connected to no sewer system here. We treat 100% of our sewage on site through these constructed wetlands that are on the outside of the building. When you guys are leaving, you can take a look, and there's some areas where you see filled with pea gravel, and that's basically our wetland areas. Our sewage will flow through these wetlands. We'll pump it back into the building. It'll be treated with a chemical and a UV light, and then we'll store that water. We will then pump that water inside the building and use that to flush our toilets and urinals. So we'll have no domestic consumption in flushing toilets and urinals. We also will capture, we have an entire green roof structure. We will capture 100% of our rainwater through the year, and we will store that. We use that inside and outside the building, and that goes to all our hose bibs. So watering plants, washing down trucks and boats in the garage, things like that. We'll use reuse of rainwater for that. We obviously have a domestic backup on everything. Domestic water will also feed your hand washing sinks and your water fountains. And then the fourth system would be the river water system. Basically that river water is pumped from the river into the mesocosms. We pull from those mesocosms, pressurize it, and it goes into the wet lab for their main experiments, and also goes out here and fills the pond up.
65?
We have 65 solar tubes bringing natural light into the building.
That light's just coming from the sun. There's not a light in there.
Obviously just to cut down on your electrical consumption of light fixtures. Even on a cloudy day, you still bring in a good amount of light, surprisingly. Energy, we will be producing. We do have plans for 2 wind turbines here on site, producing our own electric, and also
hydrokinetic turbines.
Partnering with the Corps for some hydrokinetic turbines there in the river.
So if you remember the old sickle mowers, you used to push the old sickle mowers, there was a blade that went around. You can imagine turning it out on its axis and so it's vertical and making it about 6 feet long. That's what the hydrokinetic turbine looks like. It sits there and we put it in a cage so it protects the fish and keeps it from getting debris in it. And then we cut a hole in the middle of a barge, connect the barge to the locking dam, goes up and down with the river. And if you do about 7 or 8 of these barges, you can put a lot of turbines out there, and the river current just makes it generates electricity. Submarine cable over to here, and it becomes a national research site to test out these products called hydrokinetic turbine blades.
and this will be a highly national experimental site because this is considered a low flow river. They haven't quite perfected the type of turbines to use in a low flow. So we'll have the capabilities of dropping 8 to 9 different turbines in and reading what each one is doing to see which one is best.
You know, somebody asked about, will the public get a chance, so everything behind the walls that you're going to see today from these 2 doors back are the scientific side of the building, but the public will come in here. There'll be about a 15-minute experience they'll have. There'll be sound, there'll be, we'll talk about the construction of the building, talk about what the purpose of the Great Rivers Research Center is, you know, why it's important to sustain the Mississippi River watershed. They'll be fishing here. They'll see what the rivershed looks like in terms of drawings and things. Did some sonar cameras that show live fish going down the river, that you can see the actual fish. It takes the murkiness of the river away, the way this camera works. So you can see fish going by, you know, live. And Cornell has a migratory bird satellite system, so they can tell where the birds are. They're tracking the birds at all times. You'll know what birds are coming in. And so you can come here and see, you know, what birds are in the area and if you're a birder. Things like that.
Back to the power, we're obviously also connected to Ameren. If we're ever producing more than our building would consume, we can always sell back the power to Ameren or use Ameren for anything we're lacking here on site.
You mentioned these turbines and that. Is that going to have anything to do with the turbines they're talking about putting in the dam?
You know, the Brookfield Renewable Energy is a worldwide company, but headquartered in Massachusetts. They're talking about a $400 million hydroelectric power plant at the Locken Dam. That's a gigantic scale thing. We're talking about little hydro.
I don't know if you're determining what would work best, they're going to use that in research, or?
We were doing all the environmental impact studies for them as they think about putting that turbine there, but we want to do with the engineering. Actually, that's going to cause a problem in terms of the fish getting around the Locken Dam. So there will be fish ladder studies or fish passage studies be involved in that. They have to figure out a way to get the fish around the hydroelectric.
Turn them into chum.
So we'll be involved in all those kinds of stuff. Let's take a tour.
Like Dr. Chapman said, this lobby will be open to the public year-round. I think they get 100,000 guests a year down here at the museum. So this room and the rooftop observation deck will be open to the public year-round. We have a large observation deck in the middle of the roof. We have an ADA accessible 8-foot wide ramp that goes all the way up there. But in this room, we'll have a system of green touchscreens on the wall here. Basically 42-inch plasma touchscreens, and we're quantifying everything we do here. We're keeping track of how much rainwater we've captured, how much power wind turbine 1 versus 2 is bringing in, how much sewage we've treated, and it'll all be on easy readable graphs that the public will be able to start punching through, kind of comparing everything back to a normal building this size, showing the benefits of green construction. Back there is the finish board. I can run through that real quick.
These are all LED products, recycled products.
Yeah, basically we use the highest amount of recyclable products. This is a complete poured-in-place concrete structure. In that concrete, we use the highest amount of fly ash. All our rebar running through this concrete is 99% recycled steel. All our metal studs in here are 95% recycled steel.
Fly ash.
The fly ash we used in lieu of cement in the concrete. Bathroom wall tiles, 100% recycled glass. Carpet has recyclable materials in it. Our rubber floor tiles you'll see are 100% recycled rubber. Our countertops are all made with recycled glass, and so on and so on.
My favorite is the insulation's all old newspaper, all ground up. And
interior building insulation is 100% recycled newspaper.
I tried to use as many old sound offs as I could.
A higher and better use for the telegraph.
That wasn't a far lead.
The way this, okay, basically the construction of these walls are the same as our exterior walls. We basically have a 12-inch concrete wall. There's at least a 12-inch gap, and then this stone. This stone is originally, the way it's installed, is dry stacked up, about 2-3 foot tall, and there's a series of hangers that are attached back to that concrete coming out, fingering in between here. And then there's also rebar running in that cavity also. And then they'll come from the top and fill that with a wet slurry grout. And that grout basically fingers out and grabs onto the back of all these stones.
Right out here as you leave,
it's not
there's a sample of that. You can see how it's.
Yeah, you can kind of look at one of those walls that aren't done yet. Or you can kind of get the idea of what's going across the bridge there with that open cavity.